Alright, so our first two polar videos walked us through what is polar and what do graphs of polar look like. And now we're going to start talking about the actual calculus of polar, which is derivatives and integrals. So the first thing we're going to talk about is polar derivatives. So there's a bunch of different ways to do polar derivatives, but the key point that we're going to be looking at is finding dy dx. So if you want to find dy dx in polar, that means kind of like you want the slope of the line. Well, polar dy dx is very similar to parametric dy dx, where you have a quotient, where dy dx is dy d theta over dx d theta. However, y is r sine theta and x is r cos theta, so you often have to do a little bit more work. So let me show you what that looks like. So find the slope of the rose curve, r equals 2 sine 3 theta at the point where theta equals pi over 6, and use it to find the equation of the tangent line. So you don't need to know this, but basically that polar curve looks something like this. Whoa, I apparently can't draw though. Your polar curve there looks something like this. I'm terrible at drawing those. And we want to find the slope at theta equals pi over 6. So pi over 6, I don't know, maybe somewhere like right here. And I want the slope of that tangent line to that curve. But long story short, it's really just the equation here. So if I want dy dx, I need d theta of r sine theta over d theta of r cos theta. Now what's r? R is the equation that you're given, so I need d theta of r sine theta, and then I need d theta of r cos theta. So really I just need two derivatives here, and both of them need a product rule. So let's see, I've got the first, sine 3 theta, the first times the derivative of the second plus the second times the derivative of the first, which would be 6 cos 3 theta. And then on the bottom I'm going to have the first times the derivative of the second plus the second times the derivative of the first. And now we're supposed to evaluate that at pi over 6. So I have 2 sine 3 pi over 6, which is pi over 2, times the cosine of pi over 6, plus the sine of pi over 6, times 6, times the cosine of 3 pi over 6. And then on the bottom, kind of same thing, 2 sine pi over 2, sine pi over 6, plus cosine pi over 6, 6 cosine pi over 2. There we go. So I plugged pi over 6 in for all of those thetas, and when I had 3 times theta, it was 3 pi over 6 versus pi over 2. And now, yeah, you have to evaluate this by hand. Well, 2 sine pi over 2 is just 2 times 1 times root 3 over 2. So 2 times 1 times root 3 over 2. And here, as I was writing it, I said, wait a minute, cos pi over 2 is 0. And then on the bottom, I still have a 0 because I have a cos pi over 2 in the second component, but this one, I have negative 2 times 1 times a half. So basically, these guys cancel, those guys cancel. Root 3 over 2 divided by a half is just root 3, and there's a negative. So all that work just to get a slope of radical 3, and then we're supposed to use that slope to find the equation of the tangent line. So a tangent line is y minus y1 equals m x minus x1. So I need x and y. Well, x and y come from x equals r cos theta and y equals r sine theta. So that's going to be 2 sine theta, 2 sine 3 theta, because that's r, times cos theta, and 2 sine 3 theta, because that's r, times sine theta. And then I have to evaluate both of those at pi over 6. Oh my goodness, aren't we done with this question yet? So I've got 2 sine pi over 2 cosine pi over 6, which is going to be root 3 over 2, times 2. And then on the bottom, I've got 2 sine pi over 2 again, which is just 2, times the sine of a pi over 6 is 1/2. So let's see, that's going to just cancel and be a 1, and this is going to be a radical 3. So I've got a 1 and a radical 3. So x is root 3, and y is 1. Wowzers. Wowzers, wowzers, wowzers. Okay, so what just happened here? What happened here is you take the derivative of r sine theta and r cos theta using a product rule, so you need a sum, to get a slope. And then if you're asked for a tangent line, you do r cos theta and r sine theta to get x and y, and then that will give you your equation. Y minus y1 equals mx minus x1. Wow, wow, wow. Okay, so let's see here what's going to happen on example 2. On example 2, we've got to find the slope of the curve of cos 2 theta at the point whose rectangular coordinates are this. Alright, so still slope and polar is going to be dy dx equals d theta of r sine theta over d theta of r cos theta. That's going to be, let's see, the first times the derivative of the second plus the second times the derivative of the first, and then again the first times the derivative of the second plus the second times the derivative of the first. So there's my slope, and I'm supposed to find the slope at this point, but that's not a theta point, so I need to make it a theta point. So these are x and y coordinates, pardon me. So I need to figure out what theta I'm at. Well, fortunately for us, tan theta equals y over x. So tan theta equals 1/2 divided by root 3 over 2, which if I keep switch flip that is going to be, let's see, 1 over radical 3, which is root 3 over 3. So for what value of theta do I get root 3 over 3? I get theta equals pi over 6 again. So there's my value of theta, so I'm going to evaluate that at pi over 6. Ms. Vibber, how did you know that was pi over 6? Because I know my trig rules. You need to know your sine, cosine, and tan of 30, 45, and 60, which in calculus we call pi over 6, pi over 4, and pi over 3. And so I just recognized it and did it in my head. And yeah, you got to know how to do that. So I know it stinks, but hey, there you go. So yeah, let's evaluate at pi over 6. So cosine of 2 pi over 6 is the cosine of pi over 3, which is 1/2, times the cosine of pi over 6, which is root 3 over 2. And this is going to be 1/2 times negative 2 times root 3 over 2. And then on the bottom, I've got negative cosine 2 pi over 6, which is going to be 1/2. Sine of pi over 6, 1/2. Cosine pi over 6, root 3 over 2. Negative 2, root 3 over 2, like above. So yeah, let's evaluate this. If this were free response, we just leave it like this and walk away. But let's, for the sake of argument, say it's not free response and you've got to simplify it. So I have root 3 over 4 minus 2 root 3 over 4. And on the bottom I have negative a fourth minus, let's see, what's that going to be? 6 over 4. Which is, let's see, I can cancel out all the 4's because they all have the same denominator. So I have negative radical 3 on top. And 7 on the bottom. Negative 1 minus 6. Sure. I'm going to hope that's my slope. Alright. Wow, Ms. Vibber, are we done yet? Almost. There's one more to go. So I want you guys to take a peek at example 3, and I want you to give that one a shot on your own, and then we'll come back and I will have it done for you, and I will run through my work in front of you. So press pause and do number 3 on your own. Before I finished doing what I was going to do, I just realized when I hit pause that I have a -1 -6 down here, which should make this guy a -7, which makes this a positive root 3 over positive 7, just FYI. Okay, I'm going to pause again and then do my work. Okay, so if you paused and came back, there's a lot of work on this page. I'm going to do my best to walk you through it, but some of this stuff is very challenging. So for A, you were asked to find the tangent line of this graph at theta equals pi. So I did r sine theta and r cos theta, did a product rule, plugged in pi, and got -6 over 0, which seems like, wait a minute, did I do something wrong? No, you didn't. It's telling you that the slope is undefined at that point, which means your tangent line is vertical. A vertical line has an equation in x equals 4. So I went over here and said, well, if I'm in x equals 4, I better know that x coordinate, so x is our cos theta, and here's our cos theta. I plugged in pi and got -6, so my tangent line is x equals -6. For the next one, I wanted to use theta equals 2 pi over 3, so I took the derivative from before, this guy right here, and I plugged in 2 pi over 3 and came up with 0 for a slope, which means I have a horizontal line. Horizontal lines are in y equals form, so I did y equals r sine theta, plugged in 2 pi over 3, and got 9 radical 3 over 4 for my horizontal tangent line. And then last but not least down here it says find the equation of the tangent line at 0, -3. So I said, well, if I'm at 0, -3, the point 0, -3 is down here. It would have a theta value of 3 pi over 2. So I went through and I evaluated the derivative at 3 pi over 2, and I got a slope of 1. So then I knew I had a slope of 1 at a point of 0, -3, so there's my y-intercept. So I wrote it in slope-intercept form and got y equals x minus 3 for a tangent line. So in this case, slope and equations of tangent lines are very tricky in polar. So just be aware, and we can go with that. All right, we need a joke. Mrs. Vibber needs a joke. We're going to go with a Star Wars joke today. I got 2 of them. Why is Yoda such a good gardener? Because he has 2 green thumbs. Or better yet, why is Yoda such a good gardener? Because 2 green thumbs I have. And then, what do you call Chewbacca when he gets chocolate on his fur? He would be a chocolate chip Wookiee. Alright, let's admit it. You guys, the favorite part of your video was that I did a Yoda voice. I know. This polar stuff kind of stinks, but the Yoda voice is pretty cool. Maybe I'll do the whole next video in a Yoda voice. Or maybe not. Toodles.